Hello, grade 11. So this week we have finished from our lesson, which is polynomial functions. So I'm going to resolve the two important questions. I'm going to start with the first one. We have a function which is x cubed minus 3x squared plus 2, and we need to find its limit, derivatives, that is sign, table of variation. So first of all, the limit when x tends to minus infinity, we take the highest, which is x cubed. Minus infinity cubed is minus infinity. And now plus infinity cubed, it's plus infinity. After that, we need to calculate the derivative, study the sign, then set up the table of variation. As you can see, the derivative is 3x squared minus 6x. If you do the study sign, you will get x equals to 0 and x equals to 2. Let us do together the table of variation. When doing the table of variation, first of all, we put the domain, which is from minus infinity to plus infinity. We put the two important points, which is 0 and 2. We write here the derivative and here the function. Okay? We have two roots, 0 and 2. Okay, plus minus plus inside the root, opposite sign of a, and a here is positive. Okay, so now we can tell that the function is increasing, decreasing, then increasing. Now we need to fill the important points, the limits that we already calculated. Now for x equals to 0, y equals to 2, and for x equals to 2 we have 8. We just replace 8 minus 12 plus 2, it's minus 2. Okay, now we need to draw. Okay, I'm going to do my best to make it clear. Erase again. What? Okay, this is the y-axis and this is the x-axis. Now we plot 0, 2, and we have 2 minus 2, and we need to calculate the x-intercept to tell where the function is cutting the x-axis. So to find the x-intercept, we need to put f of x equals to 0, and then we have, I think, minus 1 here, 1 and 1 roots, I think so. So just let me put it like this. This is increasing, decreasing, then increasing, decreasing, then increasing. Okay, now we need to prove that 1, 0 is a center of symmetry. 1, 0 is a center of symmetry, this point. Okay, to prove that a center of symmetry, we need to prove f of 2a minus x plus f of x equals to 2b. I'm not going to go through the calculation. Now solve the equation f of x equal to 2 and verify the results graphically. F of x equals to 2, this is the straight line. You draw a straight line of x equals to 2, and you start searching for the point of intersection of the line and the curve. So it's two solutions. Okay, now solve graphically according to the values of m the number of solutions of x cubed minus 3x squared plus 2 minus m equals to 0. This is an important question. First, you put x cubed minus 3x squared plus 2 equals to m, and you start discussing as if I'm trying to put all the cases. If I draw a line here, how many solution? If I draw a line here, how many solution? If I draw a line here, how many solution? So that's the question. Okay, below minus 2, every time you draw a line, it's going to cut the curve with one simple solution. At m equals exactly minus 2, you will have two solutions. okay? Between -2 and 2 here, every time you draw a line, you're going to have 3 simple solutions. At exactly m equals to 2, you will have a simple solution and another solution here, okay? And greater than 2, you will have only one solution. So that's the discussion. All cases are needed, okay? Now another type of questions where you have already the curve and you need to pick out all the needed information. First of all, you need to find the limit for the function when x tends to minus infinity. It's known that when x tends to minus infinity, the function is minus infinity. Also, when x tends to plus infinity, the function is going to plus infinity. Now we need to determine f of minus radical 3. It's 0 because it's on the x-axis. Also, f of radical 3 is 0. F of 2 is 2 and f of 0 is 0. Now f of prime of minus 1 is 0 because it's a minimum, and you know at local minimum and local maximum the derivative is 0. So f prime of minus 1 is 0 and f prime of 1 is also 0 because one of them is minimum and the other is maximum. Now what's the coordinates of the vertices A and B? A is -1, 2 and B is 1, -2. So those 2 points are they represent the local maximum, the extremities of the local maximum and the local minimum. Now we need to find the number of solution of f of x equals to 1. Every time I say f of x equals to 1, I have to draw a line. It's a horizontal line at 1. And see how many times did this line cuts the curve. It cut the curve on 3 points, so it's 3 solutions. F of x equals to -3, it's down, so it's only 1 solution. Now you need to solve f of x greater than 0. f of x greater than 0, يعني you are asking where's the function above x-axis, this part and this part. So you read the x-axis between minus radical 3, 0, and radical 3 plus infinity, the function is above x-axis. Sorry. Now f of x greater than 2, you put a line on 2 and you see when the curve is above 2. It's here, it's starting from 2 to plus infinity. Now the table of variation. On the table of variation, you start by the domain, which is minus infinity plus infinity. And because you have local maximum and local minimum, so these are the solution of the derivative equals to 0. So we have -1 and 1. As you can see here, the derivative is 0. Plus minus plus, same opposite same. How did we know? Increasing, decreasing, increasing. When the function is increasing, the derivative is positive. When the function is decreasing, the derivative is negative. And when the function is increasing, the derivative is positive. So it's increasing, decreasing, increasing. Now we have the function ax cubed plus bx plus c, and we need to calculate ABC. So in order to calculate the coefficients, I have to use specific points. I'm going first to start with f of 0 equals to 0 because it's the only way to get rid of a and b in order to find c. So f of 0 equals to 0 will give me c equals to 0. Now I'm going to choose 2 points like f of 1 equals to -2. It will give me a plus b equals to -2. So this is the first equation in terms of a and b. They used f prime of 1 equals to 0. Of course, you can use any other point if you want, okay? So f prime of 1 equals to 0. It gives me 3a plus b equals to 0. So this is system of 2 equation, 2 unknown. You multiply any equation by minus to get rid of b, and then you get 2a equals, sorry, minus 2a equals -2, and then a equals 1. Then you replace a by 1 and you get b equals -3. So every time you're going to have a system of 2 equation, 2 unknown, and you have to find a and b. So the function is x cubed minus 3x only because c is 0.